Hello, my name is Tarek, and today we will implement the postfix evaluation process. In the last lecture, we discussed how we can use the postfix evaluation and what steps needs to be taken to implement the postfix evaluation strategy. So today we will implement the details of the postfix evaluation process, and then we will supply some postfix values, and that the program will then evaluate and give us the answer. So here you can see the class with the name of postfix evaluation. What we did last, that we converted our infix expressions into postfix one, and then we saw how we can evaluate step by step. I showed you the step by step process, and for the sake of saving time, here I have created the class with a method that is operand. This is the same method that we used for infix conversion, the class in which we did the conversion from infix to postfix, and this method will give us the true and false value based on the token that we provide to the method. If that value is an operand, that will return true, otherwise it will return false. Now let's implement the evaluation method that will actually do the work. So public integer, because the evaluation will give us an integer value, and the method name is evaluate, and let's take a string parameter, and it will be a postfix expression exp. Right now, okay, let's declare a variable with the name result that will hold the result, and let's use a stack. The stack will, as we know, we are using stack for the for solving this problem. So stack equals to new stack, and I think it's better to use generics here, because we are using the expression with that will be in a numeric format. So let me use integer here. Sorry, integer. So it's a specialized, or you can say it's a typed stack, in which this stack now will hold only integer values. Okay, and now we need to separate, or we need to break the string based on the space, as we did in the last video, in the infix conversion video. So the string, we will take the string array, and they will say tokens equals, we will take help from the pattern class, pattern that is in the regular expression package, pattern dot compile, right? And here I'll supply on which basis it will create, or it will tokenize the given string, the given postfix string. It's based on space. So I'll say space dot split, and split what? Split this value, right? Okay. Okay. Now we have the tokens. We have a string arrays, string array, which will be containing the whole postfix expression, and now we will apply the for loop here. This for loop will one by one give us the tokens value, token, and I will say tokens. Okay. Now the first thing we will do is we will check, is this an operand or an operator. So we have a method, so we call is operand, and we'll supply the token. In case if it's an operand, then we will push that into the stack, right? So what we will do, stk, let's give it a full name, stk, this is better. So it's a stack dot push, and we will push what, token. Now it will complain because the token is in string format and our stack is in integer format. So let's convert this, integer dot percent token. Right. Okay. Else what if that token is not an operand, it means it's an operator, then it can be a plus, a minus, a division operator, an exponent operator. So what we will do, we will as we saw in the last lecture, we will pop the elements from the stack, and then we will apply the operator, right? So integer value 1 equals, or you can say operand, that will be more clear, operand 1, and we'll say stack dot pop, right? If you remember, let me show you the slides, where we have this expression, and what we will do whenever we will encounter the operator, as you can see here, we got the operator, we will pop the two top elements from the stack, as in case here we have 2 and 3. We will pop 2 elements, we will apply the operator 2 plus 3, and we have result, and we will then push the result back to the stack. Same thing we are doing here. If that token is an operand, then we are simply pushing it into the stack, right? And otherwise we will pop 2 elements out and then apply the operator. And operand 2 equals stack dot pop. Now here we can take help from the switch case programming logic, right? So I'll say switch token, right? And I'll say case, if the case is plus. Okay, if the case is plus, then the total result equals operand 1 plus operand 2, and then push the result into the stack, right? Simply push the result into the stack and break, right? So now in case 2, if we have minus, so let me copy this these 3 lines, paste it here. In case of plus, we will simply write minus, right? Okay, we are fine now, we are going good. Case, if case is multiplication, then what we will do, operand 1 multiplied by operand 2, push the result into the stack and then break, right? And the case is divide. If the operator is of division, then we will do operand 2 divided by operand 1. right? And break. Sorry. And in case of exponentiation, right? So we will do the same. Operand 2 of 1, right? Push the result into the stack. So, and now in the last, this is the operand, and this is the for loop, and after this for loop we will return the result, right? So simple. There is nothing much complicated. This method is very simple. Now we have completed our method, and let's implement the main method here. Public static void main. Okay, create the object of the class is new postfix evaluation. Postfix evaluation, let's take a complicated postfix string. Postfix equals, and I have a string which is 6 space 2 space 3 plus space minus 3 space 8 space 2 division plus and we have 2 division and plus. Okay, and now system.out.print, and I'll say ef dot evaluate postfix, right? We can also take this expression, 382 divide plus multiply divide plus multiply and 2, right? So I took the same one which I used in the last tutorial, and I am running this this postfix expression, and let's see what happens. Okay, so the answer is -7. So in this way we can simply implement the postfix method, postfix evaluation method, and we implemented the complete logic of the evaluation.